And we are live. Welcome to this latest episode, this special for Totally Unscripted. My name is Martin Hoxie and I'm joined by Steve Webster. So welcome, Steve.
Hi, Martin. How are you?
We're good. So thank you for taking a break from your holiday just to join us for this one. So we've got a great show lined up. And we've got Bruce Mcpherson joining us in a second or two, and he's going to be talking about the Video Intelligence API. So slightly different in terms of topic for us. So we thought, given that a lot of you Google Apps Script developers out there are interested in other products, it's a useful opportunity just to discover what's possible. A quick reminder before we get going with Bruce that we've got a couple of shows coming up. So as always, remember, 4th of December. So we've got a State of the Script address with Keith Einstein, who's project manager for Google Apps Script. So that one is at our usual time and day, so Thursday. And you can find more details about that on the GU Apps Script info website. And then we continue with a look at Google Tables. We got Carlin, who's the creator of Google Tables, and Ben Collins joining us for that. And then we're rounding out the year looking at some of the Google Workspace Solutions Gallery stuff and how you can contribute to that. But without further ado, and I'll just bring on to the stage Bruce Mcpherson. Hello, Bruce.
Hey, hi, Martin. Hi, Steve.
Hey, Bruce. How are you?
Yeah, very well, thank you.
So Bruce, as well as being a distinguished developer and author of the O'Reilly Going Gas, is also a musician. And so if you, hopefully, Bruce, you recognize the intro music as one of your own compositions. We're not paying any royalties for that. So maybe I should mention it. But welcome to the show, Bruce. And one of the original, actually, we're all thankful for Bruce, who's the creator of Totally Unscripted many years ago. So it's nice to have you back on the show.
Okay, so well, actually, thanks for saying that, Martin, because when you and I first started Totally Unscripted, I don't know about you, but I never really expected it to last for 4 years, which is what it's been going for. So thanks for that as we're going into season 3 with this new format that you've come up with, which I think is really pretty good. So we talked a little while ago, you and I, about things that we might be able to add to this season.
Yeah.
So we're trying out this kind of off-topic sidebar to AppScript, because when you've been an AppScripter for a while, you start to notice this great toolbox in the sky that Google have given us in the form of a cloud platform, and we figured that Totally Unscripted would be a great place to start talking about some of those capabilities, whether it's Firebase or Data Store or Cloud SQL or App Engine, Kubernetes, PubSub, AutoML. I mean, the list is endless. You'll probably all end up in amongst some of that at some point. Now, the Video Intelligence API, I've been a fan of this API since it first appeared, I think about 3 years ago, in some format. You recognize the great capability it has. And we have a little film industry startup so this is a fantastic tool for us to use, and we'll look at how we're using it a bit later on. So I won't be showing code here because the API itself is like super easy. You just essentially give it your film on Google Storage and tell it to get on with it, and it'll do lots of interesting things to it, which again we'll look at shortly. Essentially, we're trying to take films and make the content of them searchable. So before we get started on that, though, if you go to the Cloud Platform products websites, if you go to the specific reference guides and so on for the product that you want to take a look at, you've got this idea of why, what, and how. So, why are you doing something? What is it that you're doing, and how do you do it? Now, the reference guides are great for the how. They get you started, but it's not so good for the what and the why part of it. So when you go to the Quickstarts, it's the first thing it says, give me your credit card details. Then you set up the project, then you pick a language, then you download a trivial example, then you run it, and then you delete the project. And, you know, after all of that, you haven't really learned a tremendous amount about the problem you're trying to solve, or indeed if the product is going to help you to do it. So, of course, there are lots of conceptual videos and lists of features and so on to look at on the official sites too. But we thought we could use this opportunity to spend a little bit of time on the what and the why by showing finished examples of things that have been created with various cloud products that you might otherwise overlook. So it's an experiment for this show. So let's see how it goes, and if it goes okay, maybe we'll do some more of it on different topics. So we'll get to let's get started with what our application is about. So we have a database of commercials, a bit like IMDb for films, except ours is for ads and music videos. So we needed to find a way to search these films by the metadata, what it's about, who's in it, who commissioned it, and so on, but also by the content of the films, the physical content of the films. So we could ask questions like, you know, find the ad with the guy smoking the cigar in the photo booth, for example. And we didn't have to watch and manually code up thousands of ads with our content, because that would have needed millions of people and taken forever. So we needed to find a way to look at the content of ads and make them searchable. And also, since the films that we will be uploading, they're actually uploaded by the people who make them or who are in them. So that means we're going to end up potentially with different cuts of the same film. So we need to be able to find duplication, so that when the director uploads the film and then the producer uploads a slightly different cut of the film, and we need to know that's the same film, and we can't really do that digitally. So the Vision Intelligence API helps us to look at the content and find the films that are the same as each other or very similar to each other, just by examining what we find in there. So what is it? We ended up with the Video Intelligence API. It's a Google ML product. It comes with a set of pre-trained models. So they actually call them features. So you just point your video at it. It returns a huge treasure trove of data. And it's really very straightforward to use. So your job is just pretty much to dive in and start organizing the results. But first, I think we need to do some basics on how videos are organized, because that'll help us to get the right terminology as we go through the talk and make sure we're all talking about the same things. So as an aside, the film industry still refers to videos as films, even though they've only ever been digital. So I'm going to use videos and films interchangeably. So please excuse me for that. So film's really just a series of still images that are played together quickly to give the impression of movement. So these images are called frames, and they are shown at a certain rate. It's called the rate's called the FPS, or the frames per second, and typically it's about 25 frames per second, which is about the right amount of togetherness to fool a human into thinking that they're all just one piece of continuous motion. So different film encodings have different methods of compressing the film, or encoding the film and then compressing it. So the frames themselves are of two types. They're either a keyframe, or alternatively, they're a delta frame. Now, a keyframe introduces a complete change of scene. So, you know, when you watch a film, when you think of, oh, the scene's changed, at that point, that would be a keyframe. And then the frames that follow on from that, within that entire scene, are called delta frames. And what that means is they just feature the difference between the previous frame and the stuff it wants to show. So if you've got a car that's driving down the street, when you first enter that scene, you get a single image of the whole thing, and then each delta frame from that shows the car in different stages of movement, but there's not much data about the background there. So that allows you to compress the film into a manageable size, because if you didn't do that, let's say a decent quality image is 5 meg. So if you didn't have compression, you need about 7 gig to be able for every minute of film, because you'd have to have 25 complete images for every second in the film. So compression gets that down to about 25 meg from 7 gig. But it actually gives us some great material as well, because it allows us to identify scene changes and everything simply by examining the digital representation of the film. But luckily, we don't have to do any of that, because video intelligence does all of that for us. So in Google language, this change of scene, they call it a shot change. So that's the terminology that they use in the Video Intelligence API to distinguish these different shots. So I'm going to pop over to the UI over the app from time to time, just to demonstrate what's going on. Mainly I'll stay on the slides, but let's just flip over and see if we can find something. We'll take a look at a film that's got a lot of shot changes. This one, I'll play it. I don't know if it's going to play. Hopefully it's playing.
Yeah.
Okay, so this is a film with lots of scene changes. So if I take a look at the analysis of what's there, I can see all of these are shot changes. So I can see at all these different points in time, the scene changes. Okay. Now, if we take a look at another film, this one hasn't hardly got any shot change. In fact, it's got one shot change. So if I go here, you can see that the film from 1.1 seconds through to the end is just one single continuous shot. So you'll see why in a moment. This guy gets on his bike and he drives downhill through I guess it's San Francisco. And you can see that only the background's changing, really. So there's one keyframe, and then there's loads of delta frames throughout this entire film. So anyway, hopefully that gives you some background into what we're dealing with here and sets the context for the language we're going to use and so on. So let's talk about the video intelligence detection features. So what can it detect? It detects shot changes that we've just looked at. It can detect labels and logos. So it's able to know that it's able to detect a logo that it recognizes. And it takes labels, it assigns what it calls entity IDs to known things that it recognizes. So if it sees a balloon, there's an entity ID for a balloon that it then assigns to that thing that's recognized, so that you can know what it is. So it works on on shot changes, but it also works on frame over frames as well. So the most important point in the film is when the shot changes. Those are the things that are the main features of this particular scene or shot. But also other things are going to come and go in the frames in between. So it's able to detect those in addition to the things that are happening when the shot changes as well. Now, just a point on the labeling. This idea of entity ID is you'll see later on, it's the same entity ID that they use throughout Google in the Vision API and also in the Google Knowledge Graph API. So everything's nicely linked through that single code. It can transcribe speech and recognize text. But best of all for me, because this is about film disambiguation eventually, this presentation when I get to it, it can do object tracking, which means that it is able to notice a particular object when it first appears in a shot, and then it tracks it throughout its lifetime, all the positions it's been at on the screen. So that means that you can, let's say a car starts at the left-hand side of the screen, and then it ends up halfway through the screen and then it goes away. We're able to know, A, it was a car, and B, where it had been during its lifetime, which is very useful for being able to notice film duplication. So the workflow to be able to do this is the way we do it. Other people might do it differently, but so the user would upload a film in the UI, and that provokes a whole series of microservices to kick in. So the first thing is it moves it to cloud storage. Then we specify the features that we want it to analyze. So the features are those selectable video intelligence features like logo recognition and speech recognition and so on. And then we send it off to a thing called the Long Running API, which is another cloud API, because the analysis doesn't happen in your VM or in your machine. It happens in some secret place in the cloud somewhere. So there's some massive TPU, presumably, that's doing the actual recognition. So the long-running API takes care of that. And when it's all finished, it says, I'm done. Here are the results, which you then format. You're going to store it in a database, and then you're going to stick it in Elasticsearch. Now,
how long, Bruce, can it take to process, say, a 30-second clip?
Well, it depends on a bunch of things, including the density of the labels it finds, et cetera, but more or less it's in real time. So if a film's a minute long, it'll take about a minute. And anyway, so that comes back. In terms of volume, a 90-second commercial is going to make about 1,500 database rows in the way that we store it. We've compressed the data quite significantly from the, oh, my dog's just arrived. So yeah, so we compress the data quite significantly from the from what we get back from the API, but we still end up with about 1,500 rows for a 90-second commercial, which is why we use Elasticsearch, because you know, if you get thousands of commercials, that's a lot of data to look through. So all this stuff is held together by PubSub, and all the different microservices that operate on this are all alerted about things they have to do by PubSub, and we're running all the APIs on Kubernetes. So that's what the thing looks like.
So in terms of the PubSub integration, so basically, is it a case of the video intelligence API sending messages out, and then that just triggers whatever code you've got running to do next steps?
No, it doesn't work like that. The only thing that happens with the API is the only connection to the API is through the long-running API,
right?
Which is how you tell video intelligence what it needs to do and how it delivers the results of what it's done. But the various microservices are microservices that ought to do with, you know, moving stuff to the cloud, moving stuff to cloud storage, and putting stuff in databases and updating Elasticsearch indexes and everything. They're the ones that are all triggered by the, you know, this PubSub glue that goes on. Okay, so when we go to the UI and we do a search, so that in this case I'm looking at films that feature cows and chickens. Not only are we able to look now in the metadata, so you can see the metadata for the name and the synopsis and the headline, but this other stuff is things that are found in the content of the film. And so the labeling process discovered there was a chicken and a cow at shot label level, and it also discovered in the transcript of the film that it said this thing here, which included these words. I can just pop over to the app again just to show you what that might look like. So here's the cows and the chicken search, and it's found all these different things. So if we just go over the tooltip, we can see the reason that it found it there, and it's a mixture of metadata and content that was found by the Video Intelligence API. So that's pretty cool. So now we've mixed what people say, any logos or anything else that's in the film, along with encoded data that we've created manually about the film to be able to search. So let's see what's next. So we can also navigate by content. So now that we've got these searchable labeling data, we can use it not only for the searching, but also for other things, such as navigating to particular parts of the film, like feature interesting content that we might want to see. So this first screen is about, these are the number of labels of different kinds of things that found in each of the different categories of different features, I should say, that you can activate. So specifically, if we look at the shot labels, so this is the things that were going on at the beginning of each scene in this film, we can just click on these and jump to them. So let's go and do that. So that would be this film. So if I bring up the labels and I bring up the shot labels, if I want to go to where the chicken is, I just do that, and there's the chicken. And livestock and anything else. So you can see how that works. So that's really good because you're able to jump around all over the film like that. So let's go back here, and I mentioned earlier about this idea of the knowledge graph. So intelligence assigns an entity ID to each object it recognizes. Now, helpfully, this entity ID, as they call them, is actually the Google Knowledge Graph MID. So that means we can easily pull in the complete knowledge graph entry for that entity, including its Wikipedia page and everything. So the knowledge graph is in fact what Google displays when it provides that enhanced box. When you do a search engine search and you've got a thing down there, it's exactly the same information that you get in that. So we're able to pull that in just simply using the exact same code. So again, we'll just pop over here, and if I want to find out what I don't know what the chicken is, there's what chicken is. So that's not particularly useful, but it is useful for things like logos and all the rest of it. Okay, so skipping between shot changes. So we've got a note of exactly where each shot changes film. For each shot change happens. So that means we can quickly review a film by skipping through the scene changes. So if we want to just quickly see what a film's about without actually watching it, let's go back here, close that, and we'll look at shots maybe here and tell it to quickly go through. So we're just going to quickly run through the film at each significant point. So now we've watched this film in a few seconds and we know what it's about. So that's that. And the other thing is to do with transcription. I really like this. So text transcription is collected, and as is dialogue transcription. So what it attempts to do is to identify. It calls it speaker tagging. So it says, I think it was the different voice that said this than said the other thing. So it means that we can, throughout the film, you've got a constant person A said that and person B said that. So now I've tagged them up, voice A, voice B, and so on. As it happens, it's not especially accurate because, in fact, it's the same voice all the way through this film. No, actually, it's two voices, I think. So it isn't exactly accurate, but it's still a good start. And what I'd like to do eventually is to assign, I've got the cast list of every film. So ideally, I'd like to be able to assign, obviously there's no actors in this one, but when there are, it would be nice to be able to assign voice A to, John Smith and voice B to George Clooney or something, so that and put the names in here rather than just the voices. But that's a kind of a future enhancement. So let's see what that looks like over in the app. We'll close this. We'll just stay on the same film. If we look at the transcript, this is that transcript. And if we play it,
so cool and relaxed all the time. Personally, I'm more the active type. I'm like, bob and weave. But you guys just hang out all day in the sun. You're all like, mellow. What's your secret? Silence. Okay, like a Zen thing. I get it, grasshopper. I'll work on that.
Okay, so you get the picture. So that's what's happening there is we're able to just watch the parts of the film that have got voice in them as it skips through, showing us each one of these things. Okay, so logo detection. So this is pretty cool because it works. It even works for cartoons. So here it is recognizing the Nikkei logo, and it's provided its knowledge graph entity ID for it, which allowed me to go off and look up on the knowledge graph API to see more about that particular logo. And that's what that is. So it even works for cartoons. So finally on this section, I just want to show one more thing, which is about the visualization of all of that. So we looked at it in terms of lists of things and jumping around things, but it's nice to be able to just visualize the whole film. So all of these things that we looked at are visualizable as the film's playing. I'm not going to, I'll just, rather than just go through all this, I'll just go to the film and show it. It's probably better. So we choose the kind of visualization that we want here, and we can say, okay, I want to see the frame visualization. So you can see along here as the film's playing. But let's go back to the beginning, and we can hover over things to see what's going on in a particular part of the film. So let's jump to
film DNA.
There, yeah, exactly, yeah. So you can see how we can jump around, look for things, and so on. And we can do the same thing with shot changes. So these are more significant. So there's the cow-goat family, whatever that is. So it's not sure if it's a cow or a goat, so it's done them both. There's the rooster here. So that's quite nice. Similarly, you've got the text. So we can see here what it says at particular points. So that's text that's recognized in the film. Let's go there and look at that. So you can see along the bottom, sponsored by California Milk Advisory Board. That's that piece there.
Okay. Mm-hmm.
And then finally the transcript. So we can see the entire transcript here. And we can, if we like that, we can go there. Well, if it was playing.
Okay, like a Zen thing. I get it.
So let's go here.
Great cheese comes from happy cows. Happy cows come from California. Real.
Okay, so I think you get the picture now. So I'm going to go into disambiguation right now, but just before I do, is there any questions on any of that you feel would be a good time to ask them?
Yeah, the transcript portion. Could this API be applied to like a podcast audio file for the transcription?
Yeah.
Interesting. Okay.
So there is one thing, and I'll say it now. I was going to say it at the end, but I'll say it now. It's not a free API. So you usually find that doing a kind of all these feature analysis on a film on a 90-second commercial is going to cost you about $2. So it's not a thing you enter into lightly. You need a monetization opportunity before you generally apply it to everything that you do. So it's you got to think about that before you get into it, because it can rack up quite a bit of money if you run things a few times.
And just to clarify, the visualizations that you've shown here are things that you've developed with the data.
Yeah. So we've done the analysis from VI, which just provides you with a whole bunch of very raw data. We've put it into a database, and then we've put a UI on top of it that synchronizes with the film, so that it can look up to see what's happening at any particular time. So we're not doing the analysis live. We've got the analysis in the database that we then look up depending on where we are in the film. Okay, so let's move on to disambiguation, which was really the subject of this. Took us a while to get there, but all of that stuff is the raw material for how we do this. So this is the most interesting part for me, actually. It's about being able to use all this material for knowing that a film is either like another film, or it contains duplicate footage from another film. So the first question is, well, why can't you do it digitally? Well, there's a lot of people have tried, and it is possible to do it digitally, but only if the films are the same. So if you take two video files, the digest, or you'll know an MD5 digest of a file is. So if you take a digest of two video files, they'll only be the same if they're actually clones of each other. So here's three MD5s of three films that are exactly the same film, but they're encoded differently. So of course you can't compare them digitally. Now, some of the techniques that people have used in the past to be able to compare films digitally to get a kind of a video fingerprint is to do things like measuring the sound, for example, the soundtrack. You can compare the shape of the soundtrack and with another one. But the trouble with that is that we've got the same film in different languages. It's still the same film, but soundtrack-wise, it's entirely differently. So we thought, well, why don't we use this stuff that we've got anyway, for searchability and content navigation to be able to search for duplication as well. So here's an example of finding films. I think in the UI there's a button you can press to say find films like this. So this is similar content isn't the same as duplication. So we'll talk about that first. So I asked it to find films like that film we were looking at, which was this funky chicken. It said, yeah, here's a load of films that are like it. And as you can see, they all are, which is good because they're actually part of the same campaign. So it's nice that it found them. So it gives a completely automatic way to get a kind of a find more like this feature that you often find in websites. So we don't need to do any coding whatsoever. We can just say, find other things that have got similar stuff to the one I'm looking at the moment. So it compares the transcriptions, the labels, logos it finds, but in particular objects that it finds at a similar relative to each other. So that helps us to find similar content between films. So how this works is that we take a film master, and a film master is a version of a film. So one film can have multiple film masters. And we take the film master that we want to compare, and we look at each shot to see what's there. And we've seen in the first shot here, there's a chicken and a cow. The second shot's got a chicken and a balloon. And then in between the shots, there was a cow and a pig arrived as part of some of these frame labels. And then a person and a chicken arrived, and they were still there on shot 3. So that's kind of how it compares this stuff. So the labels that we detect at each shot change for all known films are compared against the target film, and then they get scored for how many objects that match are found at that point. So other films of chickens and cows are all going to score highly, and text transcription and detected logos are all going to add to the score. So if you've got a film that's about Stella Artois, other films that are about Stella Artois are going to get boosted as well. So all of that stuff adds to the score, and then to a little less degree, matches like this cow and the pig on a frame label gets added as well. So I mentioned earlier we're using Elasticsearch, because you can imagine this is going to be a pretty big search. If you've got 10,000 films, you're going to have about 15 million labels to look at. And not only do you have to look at all of these labels, you have to look at them in the context of other labels that are happening at the same time. So Elasticsearch is pretty good for that. I don't think we could do it any other way.
I guess as well, because you're referencing the shot change, if the start or finish of the video is being cropped off.
Yeah.
Because you got relative positions of stuff rather than absolute.
It's
detectable.
Yeah, you'll see a bit when we get to the deduplication. You'll see a bit more of that. It's a good point. One of the reasons that the keyframe, which is the shot change frame, is more important than the other frame, is that when people cut films, they tend to cut them at the change of scene. They don't cut them in the middle of a scene. So we're more likely to be able to not miss duplication if we focus on the shot changes rather than the intervening stuff. And similarly, similarly, you can take the beginning of a film and put it at the end, and so on, and we'd still be able to detect it because it's relative within the shot rather than relative within the film. Okay, so and then there's this idea about we have the algorithm that we use for this is tunable, because there's a kind of the idea of a content bias, and there's the thematic bias. So the content bias is about films that are about the same thing. So it'll tend to return films that are about the same kind of brand or product. So these films that we're looking at here were all returned as being similar, because they're all about, I think, pretty much all about drinking beer, all of these films. So even though they're not they've got something of a look and feel about them that's similar. But in particular, the content is very similar. It's all about people drinking beer and everything else. If we move to more of a thematic bias, then you're going to get films that are more similar in setting, style, and activity, rather than films that are about the same thing. So it's a much more subtle kind of a match. I actually like this. These films that you're seeing here, they're actually nothing to do with beer. I don't think any of them are. But the first one is because that was my target film, but the rest of them are nothing to do with that. And you'll see that you probably can even tell from the photographs that they've got the same style about them. Obviously, it's black and white, which is one measure of activity. But the film itself, if you watch it, it features crowds of people. Even this one at the bottom, crowds of people running around doing the same sort of things as each other. So that's quite a nice, surprising result that we get back on theme matching. So you can get films on content that are about the same thing, or films that kind of look like each other on a thematic basis. So now we're going to get to duplicated content, which is actually a lot harder to detect than similar content. So first of all, why do I care about duplicates? Well, as I mentioned earlier, we can have the same person uploading, different people uploading the same film, but different cuts that they've made in order to highlight something in the film that's about them. So, for example, you might get the director of the photography who's got a really great bit about, some great photography he's done, and he only wants to show that bit, and it might only be 30 seconds long, whereas the producer might want to upload the whole thing, and the company that commissioned the advert might want to upload just the stuff with their logo on or something like that. But more specifically, we've got different languages, and this has got loads of different. You can see there are different lengths and different languages and everything. So I need to be able to find out that's the same film, because if over here we've got all the metadata about the film, so we know who was in it and who directed it and what the product was and everything else. We don't want to have to recode that each time. We want to be able to carry that forward amongst all the different versions of the film. So detecting duplication on upload is really quite important. So here's an example of 3 films that have been loaded without duplication detection. So they're actually all the same film, but they're different lengths and they're different. They're really some of them are quite short. Some of them are in different orders, and some of them have got. I think they're all the same language. These ones, but anyway, the point is that the algorithm discovered that these 3 films are actually the same thing, and that they should be merged. So at this point, we in the UI would say, yeah, press that merge button. It would do that, and merge all the metadata and so on. So that's a really useful automatic find the same film as this when you're uploading stuff. So now we have to tweak the workflow a little bit to incorporate that. So we do all the same stuff as before we upload the film, and we send it to storage, and we do the same workflow as we did before to do the labeling and everything else. And then we have to tack on at the end, look for duplicates of this film, and then we have to invite the guy, say, I think it's this film, is it? Would you like to confirm it? So that's now part of the upload process as well. So talk a little bit more about how we detect the film being the same or duplicate of another film. So if you've got the same objects moving through the same position, I'm reading this, I don't know why I'm reading it, but anyway, if you've got the same objects moving through the same positions during the same time snapshot, that signals a duplication. So if imagine you've got a person, a dog, and a flying saucer and a balloon in a film segment, in a film shot, let's call it. I hesitate to call it shot because it's a little bit more subtle than that, but for the moment, let's just call it shot. So if we got all of those 4 things in film A and film B, that's a kind of a bit of a clue. It's a duplication. But of course, common objects like a person, because every film's got people in it, well, most films got people in it, they're going to attract a bit less weight than something like a flying saucer, which is a little more uncommon. Now, if the dog, the person, the balloon, and the flying saucer move through the same relative positions on the screen, that's an even bigger clue. Now, I mentioned that we had object tracking before, which is that we know that something appears at a particular point in the film, and it moves through these positions during its lifetime. So now we can know that as the dog was walking along the bottom of the screen, the balloon was flying upwards through the air to the right-hand side of the dog. So now we can know that this is really pretty good clue. This is duplication, because how many films have got a dog and a balloon moving through the same relative space? So, if enough segments, I should say, contain this kind of duplication, then we're pretty clear this is a duplicate film. So that's a technique that we use, so I've put some animation over the top of a film, and actually it's quite a tricky algorithm to tweak, as you can imagine. So and it still needs a bit of fine tuning. So this kind of animation that I've put over the top of it helps me to know if it's working okay. So these little pink overlays are the thing it's detected, where it's detected, and the positions through which the center of it moves. So if you could take this bottle, for example, the center of the bottle during the length of time, this measurement period that this was looked at over, moved through that square there. So it's probably easier if we look at the real thing. So if we go over to, let's use this actual one that's there. And now if I visualize this and play it, you're going to see these little pink boxes appearing. Hopefully you can see that. And it's saying this is the position during this section of the film that I saw these things at. So there's that one that you saw there. So that's the information it's using to be able to compare one film with another. Let's go back over here. And yeah, that's probably enough for that. So let's talk about how the object tracking structure works. Because
Bruce, before you start that, you're talking about certain objects are weighted differently. Yeah. How do you assign these weighted values? Like the bottle might be more unique than a person, so it may weight. How do you assign those?
We have like
those
millions
weights
of labels already, so we're able to know that we've got there's a kind of I can't remember the name of it now, but there's an algorithm that allows you to weight things according to its popularity, and the idea is that because we've got millions of labels already, we already have a very good knowledge as to how often pigs appear in films. So therefore, anytime we see a pig, we know that it's worth 2 points or something. Whereas a person is only worth 0.2 of a point, and a balloon's worth 10 points or something. So we know that through the data that we have collected over time.
Okay, very good. Thank you.
So if you remember that film I showed at the beginning, where we had that guy going on his bike down past all the shops, and there was one keyframe, and then there was like a tracking shot that lasted the whole film. It would be really, all we'd get if we applied this technique to a single shot is we'd get all the data for all the film in one segment, and that wouldn't really be very useful. So what we've done is we've taken an arbitrary value, and if I remember right, it's 3 seconds, that says that I'm only going to compare things that happen within a 3-second shot maximum, or alternatively within a shot that's longer. So in this film, we've got all these different scenes happening. These, and you can see the little pink blobs for how long that particular object was on the screen for, and how far it moved. So we're saying that the first shot was a normal shot, but then shot 2 came along and it was longer than 3 seconds. So we decided to split it into 2 different parts. Shot 3 was normal and shot 4 was normal. So the maximum number the maximum size of a comparison that we're making between film segments is 3 seconds. And the minimum, of course, is whatever the shot length was. Now, again, this is very early days for this algorithm, so I'm going to probably be tweaking it quite a bit as we go forward until I get this, working really, really well. But it's a good start. It's working not too bad right now. So it finds completely different cuts. So in this example, we've got 3 different. This is the Guinness advert for I don't know what, but anyway. So we've actually got 3 different versions of it. We've got this Dream Club, we've got this one here, and then we've got this one, and they've all been loaded without duplicate detection. So now now it said, I think these are the same film. It's found other films that have got, there's a 4th one that I never noticed. So there's four different versions of this film that need to be merged because it found duplication in it. And in fact, when you look at the films, they're completely different cuts. So that worked really well by that kind of technique that we just looked at. So I talked a little bit about this already. So this was to do with that long shot film that only had the one long tracking shots in it. So this is an example of something that's been split into 3-second segments so that we can take advantage of the things that are happening at the same time in the film. So I'm just about done now, but for completeness, I want to show you what it looks like as a complete system. So there's 4 steps. There's uploading the film, there's the analysis piece, there's the indexing, and there's the consumption of the things that you've indexed. So we upload the film, we check to see if it's digitally equivalent, because if it's a complete clone, I don't have to do any of that. I can just, say, well, I've got that film already, have a nice day. And then if it's not equivalent, then now we need to move it to GCS. We need to send a message to our microservice to go ahead and label it and add it to the database and everything else. We add it to our Elasticsearch pipeline, so it enters our index, and that makes it available to consume through the UI in the way that we were looking at earlier. And that's actually the end. But just before I do that, I promised you at the very beginning, I promised you the guy in the photo booth with a cigar, which is my favorite ad. So I'm just going to finish off. So what is it? Photo booth, cigar. Let's find out. Oh, there we go. So it's this one.
Cue the music.
Martin, you'll know this one, right?
Yeah.
And so on it goes. I'm going to skip it a little bit because it goes on in that vein for a little while.
Happiness is a cigar called Hamlet, a mild cigar.
Very good.
Okay, so that's that. So I just want to say a couple of things for that's the end of this totally unscripted experiment. So we're hoping that you found it interesting and useful. And if you did, then we'll probably repeat it, maybe with some other cloud platform feature, because we're all using lots of them, and it's nice to be able to just package them up and describe what you've been able to do with it, rather than just going through the starter code, and which is kind of a bit dry. So please let us know if you've enjoyed this, And I think we may have time left for questions, Martin.
Yeah. So we got a question in. So, is there any? So obviously, a lot of your UI is proprietary. Is there any code that you've published related to this, just so people are?
I'm not sure. Just give me a second.
There's a cigar called Hamlet.
I need to close this.
A mild cigar.
Sorry about that. Martin, can you stop sharing me and then?
I have.
Oh, you have? Okay. Right. Okay. So, yeah, sorry, what was the question? Have I made any of this publicly available? There's lots of
any code snippets.
Yeah. If some of you guys follow me on GitHub and on my website and stuff, I've got various bits and pieces of the building blocks of that on there. I haven't put everything. In fact, I haven't put the UI up there. I probably won't. But I'm happy to, talk to anybody about any techniques or anything that they'd like to discuss.
Is it I know you're transitioning stuff off to another domain. Is it the sites?
No, it's not the sites. It's the mcpherson.com. It's still that same domain, but it just goes somewhere different now. So I do have lots of stuff about the building blocks of the microservices and everything that's in there, but the UI and everything I probably won't be releasing.
Could you also define and explain in more simple terms what is Elasticsearch and why you picked that?
Okay, so Elasticsearch is it's a kind of a inverted index. So in other words, how can I very quickly in 2 seconds explain what Elasticsearch is? It's a way of being able to search for documents. It's a document search, and it's able to look at the relationship between things in the same document. So if I want to find A and B but not C, I can and assign weight X to D. I can do all that in Elasticsearch. So you essentially start with a database, you then load that up to Elasticsearch, which creates an index, and that index is the thing that gets used to then make these complicated queries that you couldn't really do in SQL or anything like that. There's a whole language around Elasticsearch, a whole query language that's extremely rich and extremely powerful, and can get quite complicated as well. But essentially, you do a mapping of your data to say how to handle it, how to handle queries against it, and it does things like natural language search and fuzzy searches and everything else as well. So it's really a perfect tool for this kind of idea of things that are related to each other kind of search. And being able to do it on a massive data set, which is what we have. There is a cloud version of Elasticsearch, by the way, if you wanted to get started with it. I'm actually running my own instance of it on Kubernetes because that's better for me to do it that way. But if you want to get started, then it's good. There's a free version on the cloud you can use, so it's worth looking into that.
I just wondered are there any comparable services that you looked at, or did you just go straight to the video intelligence?
Microsoft have got one too. I went straight to video intelligence, of course, because you know what it's like. If we said at the very beginning, if you're using AppScript, you're going to find yourself immersed in cloud platform stuff, and it's what you know how to use, so you tend to use it. I don't know if there are any better than this. There probably, maybe there are, I really don't know. But this does the job for me, so I'm sticking with it.
You also just have to wonder how much similar techniques school are using at YouTube in terms of indexing videos. Yeah,
it's an interesting. I had understood that they had perfected a digital fingerprint.
Right.
Because obviously they're looking for, copyright violation and everything. So I'm assuming that they've got some digital fingerprinting things that much cleverer people than me have managed to figure out how to create. But the problem with it is that then you're getting involved in analyzing the innards of videos. And what's awesome is the for me anyway, for the video intelligence API, you don't have to do any of that. You just have, all you get is the result of some clever person in the background looking at a video and decomposing it and everything else. So I think that's good. And you know, we're also looking for not quite duplication. I mean, you know, we're looking for things that are contain some of the same stuff, but not necessarily the same stuff. So it's a little bit, we're not after copyright violation. We're after the same films or the same type of films or the same theme of films.
I'm also looking. Go ahead.
After you, Steve.
Oh, sure. I actually visited the cloud.google.com/video-intelligence, and it looks like there's something called AutoML Video Intelligence.
Yeah.
It looks like that's more of a, if you're new to this, maybe you should start there before video intelligence, or do you have any comments on that?
Yeah, so video intelligence is a pre-trained model. So all the entities it knows about, it already knows about. You don't have to tell it, you don't have to train it. AutoML is if you've got some specific things you need to recognize that's not already in the library of things video intelligence goes about. You have to train it and say, you know, this is my blob. If you see one of those, it's a blob. But you have to show it what blobs look like so it can then recognize it. And that's, so AutoML will do that for you. It's just like any other ML product. You have to give it lots of training data, and then it sees other things that are like it and says, oh yeah, that's that thing. So the easiest thing is video intelligence because it's all pre-trained. The next step is AutoML, which is you know, to train it how to find objects it doesn't already know about. And then in addition to that, you've got full blast ML, which is like super complicated, and I wouldn't even know how to start to describe it.
Okay, thank you.
I was going to say, I think we're going to find how good the YouTube algorithms are when if I get any copyright violation requests.
That's a good point. I never thought of that, actually. That's really cool.
But we're using this for educational purposes.
Yeah, I think
so. That's our exception. So that'll be my response anyway. It seems such a powerful product that you've put together there. Or just in terms of the product itself, are you looking for investors? Can people?
Yeah, we will
contribute?
be at some point, but we're still in the playing around stage, and you know, the purpose of it is that people who would want to be making commercials, people who want to be in commercials, or people who want to commission commercials would be able to get together and find commercials like the one they want to make, and the people that have made them, and maybe hire those people to go ahead and do it. It's kind of like IMDb, but for commercials, and also a lot less. IMDb is very, very rich in terms of its metadata. You know, they've got lots of people who are maintain it and everything like that. We don't, everything that we do is done automatically, so we don't have huge amounts of people or maintainers. Maybe one day we will, I don't know, but anyway, that's where we are with it.
Well, look forward to seeing where it goes.
Yeah,
I think you know, with the power behind it, someone's got to invest in that. I can just see for libraries and archives.
Yeah, it looks awesome. You did a great job with that. Yeah. I mean, you probably just gave us the surface level. There's probably much more, but wow.
Yeah, there's well, I mean, right now, we're obviously just concentrating on the video intelligence part. So
I think that is taking us nicely to the end of the show. So thanks, Bruce, for joining us. I'm just going to put up if you'd like to suggest other topics for us to cover or TU specials, feel free to contact us at tu@appscriptinfo. We're always looking out for community contributions that we can showcase and highlight. Yeah, and we look forward to seeing you on future episodes of the show.
Thanks, everyone.